Hello and welcome to the Introduction to Networks, Module 3, Protocols and Models. So without further ado, let's get started. Remember, I'm going to ask you to take several notes in Microsoft Word and upload them as homework. All right, so to get started, there are rules that we have to follow when we are communicating, either as humans or as devices. So when we are communicating, there are three elements to any communications. There will be the source, the destination, and of course the channel between the sender and the receiver. And always you have to be able to communicate there's a standard on how to communicate. You can't have the sender and the receiver, for example, these two guys be able to talk to each other without, giving somebody a chance to communicate. So the message is usually taken to a transmitter. The transmitter then takes the signal, takes the message, converts it into a signal. The signal is placed on the transmission media, could be a wire or wireless, and then it's received, and then finally the signal is received and converted back into a message. The same way happens between two PCs, for example. All right, so here's the rules of establishment. In this example, you have somebody that's just writing randomly without any standard. And here is if you follow a certain grammar standard, then you'll be able to communicate. You can't just randomly say anything you want and in a different language, of course. And you can have, say, it could be in different languages. The grammar is all messed up. And so you won't be able to converse with the other person if you did that. So devices have to be able to communicate with, for example, you have to be able to identify the sender and the receiver. You have to have a common language to be able to communicate and the correct grammar. Speed and timing of the delivery is important, and confirmation or acknowledgement of requirement. So the protocols for communication protocols, please write these 4 points down. You must follow these 4 points to be able to communicate for the communications to occur. All right, computer protocols must be in agreement and also include all of the following: message encoding, formatting, encapsulation, the message size, the timing, and the delivery options. We'll go over each one of those as we move along. So message encoding, for example. You have your message, it's converted into ones and zeros, and it's converted, in other words, into a signal. It could be a wireless signal. It could be on a copper wire. Voltages on a copper wire. It could be light waves if the medium is a fiber optic cable. But it has to be encoded. And then the transmitter transmits it onto the medium. After it's been encoded, the receiver receives it, decodes it, brings it back from, the light pulses back into the original message. Okay? So when message formatting and encapsulations, your data, once the data has been converted into ones and zeros, and it's placed into a packet. And on the packet, just like when you are sending a letter, there's a place where you place the source address and the destination address. The same thing with data. Data is inside, and these are labels that are placed on top of the packet. And, routers, for example, will look at the labels to move your data. Just like the post office will read the destination zip code and trying to find where the destination of your letter is going to go to, the router will look at the destination IP address, trying to find where to send your packet to. So routers are like post offices. IP addresses are like zip codes, right? The location. The source IP address is the source zip code. The destination IP address is the destination zip code, right? So the message size, you can only send a certain amount of data. You can't take, for example, 100-pound box and send it to the post office. And if the post office told you, the limit is 20 pounds, that's all we can send, you have to go back and take your 100-pound of whatever you're trying to send and put it into smaller boxes, 5 smaller boxes, right? And relabel them. So the message size is important. You can only send, the message can be so big. If it's too big, then it has to be divided into smaller segments. Timing, you have to be able to, the message timing is very important because that will control the flow of the data, the response time, and the access method. Access method means, when, how can you, the access method is when can you be able to send the data. If you have one wire to send data and there's so many different devices want to transmit on that same medium, you can't just all jump in at the same time. If that happens, you are going to create a collision. So message timing is extremely important to be able to control the flow control of the data, the response timeout, which means, it manages how long the device waits when it does not hear from a reply from the destination, and the access method, who's going to go first and who's going to go second using the to transmit data on the transmission medium. All right, the message delivery may be one of the following methods. So this is also important. Please write this down. There is the unicast. This is when one device wants to send data only to one person. Multicast is when you want to send data to multiple users in a LAN, not everyone. If you want to send data to everyone, that's called a broadcast message. So there is the unicast, the multicast, and the broadcast. All right, this is just another way of the, in an icon method. This is a unicast, a multicast, and a broadcast. All right, let's talk about protocols. Protocols, again, are standards that devices must adhere to when they are communicating. There are protocols for networking, network communications to enable 2 or more devices to communicate with each other. Network security, for example, when they are authenticating each other, what type of encapsulation, what type of encryption method they are using to be able to communicate with each other. Routing, this is like a GPS system, finding the best route. There are multiple ways, multiple software, multiple protocols on finding the best path to the destination. And service discovery. There's a whole bunch of other different protocols that are used to communicate with other devices, with each other. All right, so the network protocols, the routers, please write these down and the description of each one of them. Now, there's a protocol on the addressing. So, for example, if you have an IPv4 address or IPv6 address, the router have to be able to know if we're all using IPv4 version 4, then the address should be, for example, 32-bit. If it's IPv6, it's 128 bits. So the addresses identify the sender and the receiver and where they are located. Reliability provides the guarantee of the delivery. So there's a protocol for that. Flow control to make sure that the data is transmitted in an efficient way. So the sender and the receiver, which we'll talk about that when we get to the transport layer of the OSI model, is we can control how much data we are transmitting. We can either slow down or speed up the transmission depending on what the receiver is telling us what to do. Sequencing. When I told you earlier that if you have a 100-pound box and you converted it into smaller boxes, each one of those boxes have to have a sequence number. Who's first, second, third, fourth. So when you transmit all of these data to get at the same time, the receiver has to be able to reassemble them. Error detection is to be able to identify that this packet or this data that was received, something is wrong with it. It's either got corrupted or somebody has been tampered with it. You drop it and you'll ask the sender to resend the data. And the application interface. All right, protocol interactions. You have the HTTP, for example. You have a web page that you want to send. You send it to the TCP, the Transmission Control Protocol, that's going to manage and guarantee the delivery of the data. And that segment is then given to the IP protocol, which is the packet, where you are going to make sure you find a path to the destination. And then the packet then given to the Ethernet NIC. For example, that's where your data is placed on the wire and going to be transmitted out. So your data is going to go through certain protocol layers of encapsulation. All right, so the network protocols will contain a group of interrelated protocols necessary to perform a communication function. It's going to set the rules that work together to help solve a problem. All right, so all of the rules, are going to apply to make sure that the data gets from the source to the destination. All right, so how did all of this happen? In the early 1970s, late 1960s, the Department of Defense, with the ARPA, the Advanced Research Project Agency, came up with the TCP/IP model. So they said, we are going to simulate the Postal Service in the United States. And the way it works, we're going to break up the whole nation into areas and give them IP addresses like zip codes. And we're going to use routers instead of post offices. And we're going to use switches like the mailman or the mail person that drives your data. And we are going to use MAC addresses. These are the number of buildings in the network itself. So a MAC address is like the number of the building in a specific land. The IP address is like the zip code of that area. The router is like your post office for that area. The switch is like the mail person that knows where all the number of the buildings are. So they came up with a 4-layered the TCP/IP model. Is called the application, transport, and the internet and the network access layer. So these are the 4 layers that came up with the TCP/IP model. Later on, they were called the OSI, which came in from the International Standard Institute. The International Organization for Standardization. And then you have the Apple Talk and the Novell. The most widely used is the TCP/IP protocol. So please write down these protocols and notice that the TCP/IP, the Internet Protocol Suite, is the most widely used. It's probably the only one that is being used over the Internet today. All right, so here's a typical example of the TCP/IP protocol, the 4 layers. All right, so your data then given to the transport layer, then the transport layer gives the data to the internet layer. This is like an assembly line. You take the data, you give it to the transport layer. The transport layer with TCP will put some labels on your segment and then pass that to the internet protocol where they put the IP addresses and it becomes a packet. Then the packet gives it to the Ethernet, and then the packet is placed into an Ethernet frame before it's placed on the wire. All right, and these are some, again, protocols on the different types of messages that you want to send. So for example, if you want to send an email, the email is given to TCP to encapsulate the data. If, for example, you want to do TFTP, TFTP gives the data to UDP to transport the data. We'll talk about these 2 different protocols later on. But for example, TCP then takes the data, encapsulate the SMTP in TCP, then gives it to the internet layer for IPv4, for example, puts the IP addresses, then it gives it to the Ethernet to place it on the wire. UDP may use, for example, IPv6 and gives it to a wireless LAN, a wireless NIC to place it on the wire, and so on. So it's really, all of this, by the way, happens from here to here inside your computer before it's given to the NIC, before it's placed on the wire. All right, so let's stop right here and we'll continue on the next video.